Probability, page 18, last page. For independent events, the probability that A and B occur is equal to the probability that A given B occurs times probability B leads to. Okay, when you have an independent event, let's go back and look at the previous page. When you have an independent event, the probability, the conditional probability of A given that B occurs is the same as the probability of A, because since A and B are independent, whether B occurs or not, it does not affect the probability of A. So, given that B occurs, A is not affected. Okay? So let's apply that here. So if you have the probability that A, given that B occurs, but B is independent from A, then this is basically saying the same thing as the probability of A. So if you have an independent events A and B, and you want to find the probability that both occur, you can multiply the probabilities of the two together. Okay. Let's do our first example. So, probability that R occurs is 0.4. The probability that S occurs is 0.5. The probability that R or S or both occur is 0.7. R, and S independent events. Well, we're going to use two different formulas that we know to solve this. One is we know how to relate R union S because we have the addition rule, which is, oops, I keep writing the wrong letter. R union S is equal to the probability of R plus the probability of S minus the probability of R intersect S. And this is true for all pairs of events, not just independent ones. Let's fill in the numbers here. So this is 0.7, this is 0.4, and this is 0.5. And this we'll just call X for now, the probability of R intersect S. So let's solve for X. We're going to get 0.4 plus 0.5 is 0.9 minus 0.7. So X, which is R intersect Y, it happens to be 0.2. Now it's asking us if R and S are independent events. Well, the probability of R intersect S, if they're independent, is the probability of R times the probability of S. What's the probability of R times the probability of S? Well, it's equal to 0.4 times 0.5, which is equal to 0.2. Wait a second, 0.2, 0.2, so yeah, they are independent events, okay? Because this is true. Alright, moving on. Number 3. If the probability of X is 0.5, the probability of Y is 0.7, and X and Y are independent, determine the probability of blah, blah, blah. And they give us a bunch of things to calculate the probability for. The first one is, find the probability of both X and Y happening. So that would be X intersect Y. Okay? So, let's see. The probability of X intersect Y, knowing that they're independent events, is equal to the probability of X times the probability of Y, which is equal to 0.5 times 0.7, which is equal to 0.35. Okay, that's A. What about B? What's the probability of X or Y or both? So that would be the probability of X union Y. The probability of X union Y is equal to the probability of X plus the probability of Y minus the probability of X intersect Y, which is equal to 0.5 plus 0.7 minus the intersection, which is 0.35. We just found that in part A. So we have 1.2 minus 0.35, which is 0.85. Okay, what about C? Neither X nor Y. Neither X nor Y. So that would be the neither X nor Y. So it would be X union Y complement, which would be equal to 1 minus the probability of X union Y. which is equal to 1 minus 0.85, which is equal to 0.15. Right? What about D? Probability of X but not Y. So X intersect with not Y. So that would be the probability of X times the probability of not Y, because remember they're independent. Probability of X is 0.5. The probability of not Y is 0.3. So the answer here is going to be 0.15. What about E? X given that Y occurs. So probability of X given that Y occurs, which you can find this by doing probability of X intersect Y divided by the probability of Y. Put this up here. So let's see. Probability of X intersect Y is 0.35, which is part A, right? And the probability of Y is 0.7. So 0.35 divided by 0.7 is 0.5. Okay. Number 5. Find the probability of getting at least 1 6 when a die is rolled 3 times. This is actually kind of a lengthy problem if you do it in a straightforward way. If you do it with a trick, it's quite quick. Think about, let's see, getting at least 1 6 when a die is rolled 3 times. That's actually like a compound event, right? It's like you could get a 6 on the first try. You could get a 6 on the second try. You could get a 6 on the third try. Then you need to go through and say, oh, what if I get 2 6s? What if I get 3 6s? So there's actually many different ways for it to get 1 6, and you'd have to add up all those probabilities. But you could do it a different way. You could think of it as, what is the probability that I'm not going to get any 6? And that would be the complement of that. So let's figure out what's the probability of not getting any 6. To figure out what the probability is of not getting any 6, you would multiply. On the first roll, you'd have a 5/6 chance of not getting a 6. On the second roll, you would have a 5/6 chance, again, of not getting any 6. And on the last roll, you would have a 5/6 chance of not getting any 6. And as a result, you would have 5 times 5 times 5, 125, divided by 6 times 6 times 6, which is 36 times 6. Don't know that in my head. It's 216. So the probability that you could get at least 1 6 would be the complement of that. So you would do 1 minus that. It would be 216 minus 125, which would be 91 over 216. So that would be A. B. Find the smallest n such that P, the probability of at least 1 6 in n rolls of dice, is greater than 99%. So let's see. That would mean 5/6 n rolls is greater than 99. Oh, I'm sorry. It's actually going to be less than 0.1 because it's the complement. 0.01. One of the ways you could do this to solve for n is you could use logs, right? If we do take the log of both sides, then we're going to get n log of 5/6 is less than log of 0.01. And the log of 0.01 is -2. And log of 5/6, let's check here on the calculator. 5/6 is 0.8333. The log, base 10, of 0.8333 is -0.079. So I'm going to have n times -0.0792 is less than -2. And then I'm going to divide both sides by -0.0792. And when I divide by a negative number, remember that you do need to reverse the inequality sign. And then I'll get n is greater than 25.25, which means n is equal to 26. Okay, 7, last one. Suppose that the probability of A intersect B is equal to 0.1 and the probability of A intersect B prime is equal to 0.4. Find the probability of A union B prime given that A and B are independent. Okay. This is probably the oddest problem we've had so far. They said that these are independent, so what can we do with that? Well, we do know that the probability of A intersect B is equal to the probability of A times the probability of B, right? So let's write that out in an equation. Probability of 0.1 is equal to the probability of A times the probability of B. Okay, then let's look at this one. So the probability of A intersect B dash is equal to 0.4, which is equal to the probability of A times the probability of B dash. Okay, and then we do know that the probability of B dash is equal to 1 minus the probability of B. So probability of A times that is 0.4. Now let's multiply it out. So we have 0.4 equals the probability of A times, or minus the probability of A times the probability of B. Oh, but we do know the probability of A times the probability of B is 0.1. So we have this as 0.1. And then we can do algebra, and we'll discover that P of A is equal to 0.4 minus 0, or 0.4 plus 0.1. So probability of A is actually equal to 0.5. And now we know that 0.5 times probability of B is equal to 0.1. So the probability of B is equal to 0.1 divided by the probability of A, which is equal to 0.1 divided by 0.5, which is 1/5, which is 0.2. So now we have expressions for probability of A and for probability of B. So we can also figure out what the probability of B dash is. It's going to be 0.8, right? It's going to be the complement of 0.2. Now we really have everything we need to figure out the probability of A union B dash. The probability of A union B dash is equal to the probability of A plus the probability of B dashed plus the probability of A times, minus the probability of A times B dash. Okay, so probability of A is 0.5. Probability of B dash is 0.8. Probability of A is 0.5. And the probability of B dash is 0.8. So that's equal to 1.3. And 0.5 times 0.8 is 0.4. And the answer is 0.9. And that's it for this page.